Example 6 on page 527. Add or subtract simplified by collecting like radical terms, if possible. So we're given here two terms with the cube root radicals. Alright, before combining these two terms that involve radicals, you need to check if the radicals of these two terms met these conditions. So first, do they have the same index or k root? Yes, right? Because this is q root, this is q root. So k equals 3, k equals 3, they match. So the first condition met. How about the second conditions? The radicand of this first term right here is 16y to the fourth. The radicand of this term is 2y. They don't meet, okay? Because they are different. 16y to the fourth is different from 2y. So you cannot combine these two radicals, yes. But notice that the radicand here is 16y to the fourth. It's not prime. This coefficient 16 is not prime. And y to the fourth, this fourth right here is greater than 3. The exponent 4 is greater than 3. That means you can rewriting y to the fourth in terms of 3. Okay? That means you will factor y to the fourth to y raised to the third power times y. Right? So that means you still can simplify the radicands. So in a sense, you would try to simplify this radicand and make it equal to this radicand 2y. Because if radicand of this term is 2y, then you can combine with this second term here. So we have 5 times q root of 16y to the fourth plus 7 q root of 2y. Alright. Q root. Now we learned how to factor 16. 16 is 2 to the fourth power. Okay? And y to the fourth, again, y to the fourth you can rewriting in terms of 3 exponents. Make it y to the third power times y. Because y to the third power times y is y to the fourth power plus 7 q root of 2y. For this radicand is done because the coefficient 2 here is prime, so you cannot factor any further. And this y has exponent 1, which is less than the k root 3, so no way you would make this y equal to 3. So leave it as is. So 5 q root. Now, before I approach, and you see that we can rewriting this 2 to the fourth as 2 to the third power times 2, so that this 3 exponent match with the k root 3 right here. Once they are the same, you can bring this 2 out, okay? The reason I want to make the space here because the y to the third power, the y has exponent 3, right? Match with the k root 3 right here. That means you can bring the y outside the q root. Again, because this is k equals 3, which is odd root, you don't have to worry about putting the absolute value around the variable y. Alright, so we factor to the fourth to 2 to the third times 2, and this y to the third, bring it out because it has same exponent 3 with the k right here. Remaining is y. Plus, this term just copy it as is, 2y. Now, this 2 to the third, you can bring it out because the exponent 3 equal to k equals 3 here, so I will factor the 2 out. This term is out, so remaining is 2 times y, okay? Plus 7 q root of 2y. I'm going to continue from here, okay? Equal. Simplify this. 5 times 2 is 10. 10 times y is 10y. And then q root of 2y. Okay? And then this is plus 7 q root 2y. Alright, now we have simplified this term to this term, which is 10y cube root of 2y. And you notice now the two radicals still have k equal 3, right? The index 3, which is cube root, which is good, satisfy this first condition. Notice that this time the radicands of the two roots are the same. This radicand right here is 2y, this radicand right here is 2y. So that means it satisfies the second condition. Then we're ready to combining the two radical terms. Okay? So to combine, so treat this cube root 2y has some variable, similar variable, okay? So that means you just rewriting is here. Okay? And then 10y plus 7. Make sure you're using the parentheses because this cube root 2y is the factor of the two terms inside the parentheses, okay? So the answer is you take 10y plus 7 and the result, everything multiplied by cube root of 2y. It is answer for simplifying the two radical terms.